Alright, so what we're doing today, this is the DL meter. So what I'm going to do is I'm going to throw it in the water, and it's going to record the dissolved oxygen, temperature, and as well as the percent saturation. So I'm going to throw it in this water, which looks kind of green. So we're going to get some interesting levels of DO and stuff. Alright guys, we're out. My $100. Alright, that's it. That's how you get the measurements. Pretty tough. So this is our last spot. It looks pretty polluted, so we're hoping for very high levels of nitrate. Probably all the crud that runs off into the city probably ends up here. We're hoping that there will be high levels of DO due to this larger area of algae biomass. So yeah, we're gonna measure it. Alright, let's go time. So today we'll be using ArcGIS map for our spatial analysis of our dissolved oxygen project. As you can see, there are 4 data values which correspond to our trip to these 4 different locations. And through ArcGIS map we can actually click on each of these data values to see information about each site. So what I have here is the city of Merced, and you can see different colors. The yellow color represents the city county, and the brown actually represents the urban area of the city. Now we have the green area that represents mostly agriculture, and we have like major bodies of water that's in the color blue. Now today we actually have a shapefile, or also known as layers, that I'll be using. Specifically, I'll be applying a layer that represents all the rivers going through our city. So I'm going to press it now, and you'll see a very distinct change in our map. So now you can see all the different veins, which are the rivers itself. And we're most interested in this river here, which is the Bear Creek. It's kind of hard to actually make sense of this map itself because there's just so much going on. So what I did was I actually selected an attribute under this shapefile, and I was able to narrow it down to just Bear Creek. So you have this purple layer now, and that's Bear Creek itself, and you can kind of see that it fits perfectly with our 4 data values. So I wanted to know where exactly would these pollutants come from. For instance, you have urban, agriculture, and pre-agriculture. So you kind of want to break it down into those 3 sections. So that's what I kind of did, is I did that. So I'm going to apply the next river that would be responsible for some pollution. This is called Black Rascal Creek, and it basically contributes near the end, as you can see. So that's one river that might contribute to our river, the observed river that we're trying to analyze. The next river would be Bradley Lateral, and you can kind of see that it's this light teal color here, which contributes in between our second data point and our 3rd data point. And then our next layer that we're going to apply is the Fairfield Canal. It's a bit hard to see, but you can kind of see that it's this green, darker green river that contributes before the 2nd data point and after our 1st data point. And our last river is La Grande Canal, and it contributes right before the 1st data point. So right here we already have 4 rivers that could potentially contribute to our data set. So this is a way of kind of backtracking to see exactly where is the runoff coming from, and where does all the water go. So this is one way of utilizing spatial tools to see where exactly is how is your data affected by the environment it's surrounded in. We normally cannot see this without this type of tool. It would take hours just to drive up to these locations to find these rivers. But with ArcGIS, you can just map it and then just see exactly what contributes to your experiment. So that's pretty much it, and that's how we use our spatial tools to analyze our experiment. And from here, we can actually expand this experiment even more. Hopefully, one day another student might actually visit these other rivers that contribute to Bear Creek and see if those rivers are higher in pollution, and perhaps we can narrow down a certain river that actually is higher in pollution, which could potentially mean that something around that river is polluting the water around the entire environment, which is highly unlikely, but it's a good shot.
That was nice. That was awesome. Learned so much.